from JPS Reliability and the Reliability Training Institute RMS. What I'm going to go today is case study 4. This is 4 or 5 case studies we're sharing with you. As per the previous 3, we're going to talk about the failure cause, the mechanism, and the mode of failure. We're going to be referring to MIRCE science, where we're bringing the reality and the theory together as well. So this is number 4. I don't know if you've seen the other 3, but if you would like to view the other 3, please go to the RMS website, and there will be links there to show the 3. The first one was an electrical motor connection defect. This is where we picked up a defect on the motor through vibration analysis. Also highlights the need to use other technologies like thermography. The second case study was on a fan motor bearing, where we had transferred vibration from another running asset, which caused a failure, highlights another problem. The third one was a very interesting one on the variable frequency drive defect on that IVI card. And today we're going through the vibrating screen gearbox bearing defect. These are all practical examples from real life case studies. These are actually case studies from my book I'm just published. I'm enhancing reliability through vibration technology. An overview of the book again can be found on the RMS Reliability Maintenance Solutions website. I've got a short video talking about the book. Okay, so let's get into this case study then. Many of you know this is an exciter gearbox. So we have 2 shafts with concentric weights. They're used in the quarry and mining industry on screens or shakers to shake down the product through different sizes. You usually have 1 or 2 across with a jack shaft, and they run, and as you can imagine, they vibrate heavily to vibrate the product down the line. In this particular defect at this site, they were having problems with gearboxes failing. Their current way of detecting the mode of failure was on the operator walkarounds. They would use a temperature gun, and when it was hot, they knew it was going to fail within the shift. So the issue here was detection to the PF interval was too short, because then they would panic around and try and get it. We offered to do a vibration analysis survey to see if we could find a defect. This was the peak view data from the short shaft, I think it was. As you can see, 2 Gs, but here what we can see very lovely is an impact which matched the calculated defect frequency for the inner raceway, side banded by run speed harmonics, and harmonics the defect. So I was quite impressed that an inner race in this gearbox has a defect which the energy is that high that it transfers from the wrong element to the outer race, to the casing, the outside of the gearbox, which itself is shaking at over 100 millimeters per second, and we pick up the transducer, and we even pick up the modulation as the inner race defect is coming close to away from the bearing. Due to that particular fact, our class is very urgent, and they needed to schedule in, remove the gearbox before it's short notice and it functionally fails. Luckily enough, they did remove the gearbox before it failed and affected the system and the functionability. And what we found on each bearing, actually, on both the shafts, was an area of spalling. Also, as the bearing was fading, is again overroll within the lubricant. So we had to look into why that was happening. When we actually looked at when we took it apart, so before we took it apart, we marked up all the bearings, drive end, non-drive end, top, bottom, and where the weights were, more importantly. And so happened that on the furthest part of the weight swing, where you get the load, the shock, it's in the same place, because the weights are bolted to the shaft and they don't move. They're with the shafts that turned around. So the same point in that inner race is under the highest stress all the time. And again here, on the opposite side where you got some carryover, you can see it started to damage in the race. So we had an inner race defect, picked up beautifully with vibration analysis. So this shows you that if you know your system, you're monitoring the correct parameters, be it velocity, acceleration, displacement, some bearing condition unit, peak view, SPM, HDS, lots of technologies. If you're monitoring the correct stuff, sampling correctly, you will see the defect. Often I hear people say, oh, vibration analysis is no good, didn't find a defect. Well, it may have not seen a defect if you weren't monitoring the correct parameters for that failure. So it brings two things to mind. If you don't know the system you're monitoring, what failures can affect in that system, how can you set your database up to monitor them? And you need to know how to set your database up to monitor the correct frequencies. So it's all about training, mentoring, and experience, basically. So when we took a step back and we looked at it, I've also got some other experience with these gearboxes. What it happened is, when they shut down for the weekends, or they shut down for maintenance, the oil would obviously go to the gearbox at the bottom. Now the gearbox is at 45 degrees, so a little corner bit of the gearbox has the oil. It has the right amount of oil and the correct lubricant spec from the OEM. But what actually is happening is, on the split second on startup, as the weights come around, at one point of that inner race is the highest loaded bit, there's not enough lubrication there. So it's starting to really squeeze that bearing in the elements, and you're getting your subsurface fatigue, cracking, and then spalling. So the failure cause is inadequate lubrication. The mechanism of failure is the overload, instantaneous overload on startup with an inadequate lubrication. And the failure detection mode was through vibration analysis, and there's an inner race spalling defect. So the random inspection, in the sense it is random that we were doing a trial to prove, so they can have a higher PF curve and they know they can plan and schedule it out. We found a hidden defect, which they would only find this defect once that inner race has spalled so much that you're generating a lot of heat in the gearbox and it's picked up on the operator's checks. Well, positive action was put in place to restore the functionality of the system. So we did a control change out. They changed it before it failed and had a functional failure. The system could still carry on, produce X amount of product to the customer, and it did not affect the business. In addition, we suggested using a superior lubricant. So this is a type of oil that when the gearbox will stop, it's got additives in it and it actually sticks to the bearing. So it reduces the probability of the instantaneous overload and the damage to the bearing. And in some sites where we've done this, with this particular oil, it has eliminated an inner race defect on this particular model, which we found out seemed to be a bit of an issue. Again, we're very, very passionate about sharing knowledge and enhancing people's knowledge of vibration analysis and condition monitoring in general. So at the Reliability Training Institute, we deliver courses which are conforming to 18436 with Mobius training, so you either get MIBOC or BINT certification. We can do practical upskilling of your team on site, and remotely as well. We can support remotely with upskilling, and we have the traditional contracted out reliability services. I like to keep this slide in because it emphasizes these are the four main technologies. There is obviously motor current analysis and electrical signature analysis used as well, but these are the four main ones that we use, and it shows you that they all have their motor detection. For instance, on this failure with the exciter, they were using thermography, and it would pick it up before it failed, but they were really at the point of failure. Whereas adding vibration analysis now, we can get bearings, but we get it earlier. It gives them more lead time, keep less spares on the shelf, and they can schedule it in without affecting production. And again, ultrasound would be gold in this area. Contract ultrasound, you will pick up those stress rates really, really well, and lubrication as well. If you did lubrication analysis, you will pick up the particles in the oil. This shows you all four must be used together to have a really good system. That's the same slide from the previous three, which is a little bit about myself and the link to my book. This slide again explains the MIRCE science and what we've been working with the doctor on bringing the reality and theory together. Please go on his website and have a look and try and get in contact with the doctor. Very, very knowledgeable and helpful person. So thank you very much for listening to this fourth case study. There's one more in the series to come, and please do keep a lookout. And if you have missed the previous free, go to Reliability Maintenance Solutions website, and there'll be a link on the blog, and you'll be able to see them all there. And also there'll be lots of really great information on our website. Thank you very much.